class, welcome to our next lesson for today. We take a clue from what we did in our previous lesson, that was trigonometry and its angles. Today we'll be looking at complementary angles. There's a subtopic under trigonometry. When you talk of complementary angles, they are angles that add up to 90 degrees. Now today we'll be looking at sine and cos under complementary angles. When you have values under sine and cos, supposing you have sine 60. Sine 60 under complementary angles is also the same as cos 40, cos 30 rather, because 30 plus 60 add up to 90 degrees. Now, I can give a diagram, but before that, we have complementary angles. And I said earlier on that complementary angles are angles whose sum add up to 90 degrees. I'll draw this diagram to illustrate and explain the complementary angles under sine and cos. I'll have my R, P, and Q. Now the opposite side of Q is line PR. So I'll write my small q at line PR. Then the opposite line of R is also line PQ. So I'll write small r also here. We also have the opposite of P, which is line QR. So I'll write small p also here. P, which corresponds to line QR. So I have my small p there. Now we look at sine and cos in our discussion today. So I will take sine R. In the discussion in our previous lessons, we said sine is equal to opposite over hypotenuse. So we look at where the R is. The opposite line to R is the small r on line PQ. So I'll bring my equal to and write my small r divided by the hypotenuse side of this triangle is line PQ. Line QR, where we have our small p. So I'll write my p as the hypotenuse. Now I can name this as equation 1, and I'll write the same thing for cos, because we said that in complementary angles, sine and cos always add up to 90 degrees. And so I will take an angle for cos at Q. So if I take Q as my cos, I have cos Q, which is equal to, now we have this side as opposite. We have QR as hypotenuse. We also have PQ as adjacent. We are taking the angle at Q. So cos Q will be equal to Q over, cos is adjacent over hypotenuse. So it will be R over P. And I'll name this one also as equation 2. Now you see from equation 1 and equation 2 that sine R, which is R over P, is also the same as cos Q, which is also equal to R over P. So this proves that when you have something like sine 60 degrees, sine 60 degrees is also the same as cos 30 degrees because they all add up to 90 degrees under complementary angles. Now, so there is always a clue in solving questions under complementary angles. Suppose you have been given sine 50 degrees and you are asked to find the vice angle, which is the cos. Since we have the sine, which is sine 50, the opposite angle in our discussion for complementary angles will also be equal to cos brackets 90 degrees minus 50 degrees. In this case, when you subtract 50 from 90, it will give us cos 40 degrees, meaning that when you add 50 and 40, it will give us 90. So we can take an example to prove whether what we are saying is true. So in our example 1, we can say that without using calculator, or tables, find the values of two sine 40 over cos 50 plus cos 22 over sine 68 degrees. Now, to be able to find the value of this, we apply the principle of the complementary angles under sine and cos. Now we are having 2 sine 40 degrees over cos 50. There is a need for us to change either the cos or the sine, so that we can have the same ratios, either sine over sine or cos over cos, so we can do cancellation and simplify it. So in this case, we can change sine 40 into cos. So in our solution, it will be 2 cos brackets 90 degrees minus 40 all over. Since we are changing the sign to cos, we maintain our denominator cos 50 plus, we can also change the cos on the other side, which is cos 22, to sine. So we have sine brackets 90 degrees minus 22 degrees all over sine 68 degrees. Now you can do subtraction. So you write our 2 cos 90 minus 40 is 50 degrees over cos 50 degrees plus sine 90 minus 22 will give us 68 degrees over sine 68 degrees. Now you look very simple now. We can do cancellation. So cos 50 will cancel cos 50. Sine 68 also cancels sine 68. Now we're going to have, this implies that we have 2, when cos cancels cos, it will leave 1. 2 multiply 1 is the same as 2 over 1 plus 1 over 1. That is sine 68 cancels sine 68, leaving 1 as numerator and 1 as denominator. So 2 plus 1 is 2 over 1. So therefore 2 over 1 will give us 2. So therefore, our question given to us, 2 sine 40 over cos 50 plus cos 22 over sine 68, has now given us 2 as our answer. Thank you. Sorry for a wrong calculation made here. We can make some corrections. Sorry. So 2 over 1 plus 1 over 2 isn't 2, but it is 2 plus 1, because 2 over 1 is the same as 2 plus 1 over 1 is the same as 1. So therefore 2 plus 1 will give us 3. So that is the right answer for our calculations we did under the question given. It should be 3 as answer to the question. So I'll claim the first mistake I made, which wasn't 2. It is now 2 plus 1, and that will give us 3. And so when we look at the question very carefully, and then the illustrations we gave, and then the analysis we have made so far, it is clear that complementary angles between sine and cos are always the same. When you have sine 0 is the same as cos 90. 0 plus 90 will give us 90. So any value or any calculations under cos and sine for complementary angles always add up to 90 degrees. So you can also try another example to see and to clear the minds of others who may have difficulties in the calculations of the complementary angles. So let's go through one more example and see. We take our second example, that will be example 2, without using tables or calculators. Evaluate. This is our second example. Okay, so in our solution, still applying the principles under sine and cos. So sine 45 degrees minus, we have cos 80 over sine 10. 90 plus 10 plus 80 will give us 90. So we can change one of them to get same ratio for sine or for cos. So I will change the sine to cos. So I'll maintain the numerator cos 80 degrees. Cos 80 degrees over cos brackets 90 degrees. So cos 80 degrees over cos brackets 90 minus 10 degrees. Since you want to get the same ratios, plus sine 50 degrees over, we also want to change the cos. So 2 brackets or 2 sine brackets 90 degrees minus sine 45 degrees minus cos 80 degrees over 90 minus 10 will give us cos 80 degrees plus 90 minus 50 will give us cos 40 degrees over 2 cos 40 degrees. Now you can do cancellation. cos 80 will cancel cos 80. So you maintain our sine 45 degrees minus cos 80 cancels cos 80 will leave us 1 over 1 plus cos 40 also cancels cos 40, leaving 1 over 2. There will be 2 here, but there's 1 left here. So 2 multiply 1 will give us 2. So in this case, we have to simplify sine 45. Now when you press your calculator or you punch your calculator, sine 45 will give us root 2 over 2. So we have root 2 over 2 minus 1 over 1 plus 1 over 2. 1 plus 1. But there's minus here. So minus 1 plus 1 can be 0. But you can choose to find LCM. So I will find LCM, which is 2. 2 goes into 2, which is 1. 1 multiply the coefficient of the root, which is 1. So it becomes root 2 minus 1 who goes into 2 is 2 times. 2 times 1 is 2. Plus 2 goes into 2 is 1. 1 times 1 is 1. Is that root 2 1 will give us negative 1 over 2. And therefore, the coefficient of the square root of 2 minus 1 is 1. So you factor 1 out. Then the coefficient of the denominator 2 is 2. So you factor the 2 out. Open brackets, square root of 2 minus 1. This is our final answer for the second example. So when you look at it very carefully, applying the sine rule does not sometimes need much use of the calculator. So it's very simple. Just know the addition and subtraction. Sine and cos always add up to 90 degrees under the complementary angles. So this is a very good analysis and a very good calculations under the complementary angles. So we started by saying that complementary angles are angles which sum add up to 90 degrees. Complementary angles are only used for the sine and the cos, meaning that a value for cos, it's vice versa, is for sine. So all values and the calculations for complementary angles are always the same. And so I think I have made a very good use of the time, and time will not permit me to give you exercise for you to do, for me to mark. So what I will do is that I will post exercises on my wall. So you visit on my wall the email address I give you, the dates or the time I give you for you to visit and have a discussion and chat with me, so that we can discuss your problems and analyze what you don't understand, so that when you come back to class, we can see the way forward. Thank you very much and have a fruitful day. We meet again in our next lesson.